Hi all, welcome to my channel. In this project series, I'll be designing and building a DIY UV curing chamber for resin printers. Of course, everything will be open source, and I'll be providing instructions on how to build your own. In this first part, I'll give an introduction to resin curing chambers and an overview of the project. If you already know about how resin printers work and why a curing chamber is helpful, skip to this point in the video. But what is a UV curing chamber and why is it needed? Most resin-based 3D printers create 3D parts by selectively exposing a plastic resin to UV light. When the resin is exposed to UV light, it transitions from a thick resin into a solid. While there are several ways to selectively expose resin to UV light, all resin printers work on the same basic principle. Some 3D printing resins, especially engineering resins, need to be exposed to additional UV light after being removed from the 3D printer. When printing, it is common to expose the resin to just enough UV light to solidify it and save time. While this produces a solid part, it doesn't result in the part having the optimal material properties. This is where a UV curing chamber comes in. The UV curing chamber is simply some kind of container with UV lights inside of it. They are often reflective on the inside to make better use of the available light. After the print is removed from the printer and washed, it is placed inside the chamber where the resin can fully react to the UV light, thus enhancing its material properties. My resin 3D printer is a Form 3 made by Formlabs. They sell their own curing chamber for their printers. Having personally used them at my college campus, I can say that they work extremely well and I get amazing results nearly every single time. There's a big drawback to this product. Yeah, that's a lot. Not many people can afford that. That brings us to the goal of this series, designing and building an open source DIY UV curing chamber. Let's take a look at the DIY curing chamber I'm basing this project off of. Adam Savage's Tested made a pretty good curing chamber on their YouTube channel. I have a link to it in the description, but there's some big improvements I really wanted to make to their design. There are two main issues I had with this design. The official form cure has a heated chamber, while this design does not. I looked around on YouTube, and all the designs I found for DIY UV curing chambers do not have a heated chamber, which isn't optimal because heating a part while it's curing is extremely beneficial. It decreases the time needed inside the chamber to fully cure it drastically. Additionally, some of the Formlabs engineering resins require the curing chamber to be heated for optimal material properties. I looked around for quite a while to try to find a DIY curing chamber that's heated with no luck. Second, the chamber that Tested built has a weird timer with fixed time intervals. While it's much easier to set up a system like this is very limiting in terms of what the chamber can do. Here are my goals for this project. A heated chamber. The curing chamber should be able to heat to a specific temperature and hold that temperature. A turntable. Rotating the part on a platform allows for a more even application of UV light. Easy to use touchscreen graphic user interface. Touchscreens allow for intuitive and effective user interaction. Customizable profiles for different resin types, easily selectable from a list on the touchscreen which can be edited on the unit. A built-in timer for scheduled start times. I want to be able to set a timer on the curing chamber so it's ready when the print is finished once I start the print. How am I going to accomplish all these goals? With the use of an Arduino microcontroller. If you aren't familiar with what a microcontroller is, I've linked a video in the description about what a microcontroller is and what Arduinos are. Let's break down the components needed to accomplish these goals. Arduino Mega. This will be the brains of the operation. A touchscreen display. This is how you will interact with the device. A hairdryer. Hairdryers are a cheap, common, pre-made product that has a heater and fan and are designed to work safely and turn off if they get too hot. A turntable. Many microwave manufacturers have parts available online for their microwave turntables in case the motor fails. We'll be using one of those. UV LEDs. Relays. Relays are an easy and effective way to control high-power devices, especially those running on alternating current. A steel bread box. This is the main structure of our curing chamber. It's already reflective on the inside and has a nice door that will keep the heat in. A 3D printed housing. This will hold all the electronics, the touchscreen, the microcontroller, the relays, and some 3D printed parts for things like the turntable, and ducts for the hairdryer. I'm excited to show you all the work that I put into this project so far. In the next part, I'll show you all the parts I bought for this project, and I'll start working on the GUI for the touchscreen. If you have any suggestions for features to add to this project, please leave them in the comments below. If you want to know when the next part of this series is uploaded, subscribe to my YouTube channel.